In today's class, we will see about what is electrocardiogram. Electrocardiogram is the electrical activity that originates from the heart, from the surface of the body. In the clinic, the ECG is one of the most commonly used diagnostic machines. The recording produced by the electrocardiograph is called as the electrocardiogram. So the recording is called as the electrocardiogram and the instrument is called as the electrocardiogram. So here you can see the picture of the heart. So heart has four chambers, the right atrium, right ventricle, left atrium and left ventricle. So here in between the right atrium and the right ventricle you have the tricuspid valve, left atrium, left ventricle you have the mitral valve. So from the tricuspid left ventricle, from the right ventricle, the blood will flow to the lungs through the pulmonary valve. So from the pulmonary valve it goes to the lungs, the blood gets purified and pure blood will flow into the left atrium through the pulmonary artery. So left atrium will get pure blood will come to the left atrium, left ventricle, and then it will go to the aortic, through the aortic valve through to the other parts of the body. So here in this circulation system, impure blood will flow from the superior vena cava and the inferior vena cava into the right atrium. So right atrium, when it is filled with blood, at the same time the pure blood is filled with will be filled in the left atrium. Simultaneously this will get filled, this will get filled. So once this is full, this valve will open. Once this is full, this valve will open. So the impure blood flows from the right atrium to the right ventricle, and this valve, once this is full, this valve will close and the blood will be forced into the lungs through the right pulmonary artery. So here it gets purified, blood gets purified by the exchange of carbon dioxide and oxygen from the breathing respiratory system, and the pure blood will flow into the left atrium through the left pulmonary artery. So once this is full, this valve will open, this ventricle, left ventricle will get filled. So once it is filled, the blood will be forced to the other parts of the body through the aortic valve. So since it is forcing blood to the other parts of the body, the heart muscle of the left ventricle will be thicker than the other parts of the electrical activity from the heart. So here the heart, the main parts of this heart here, electrical parts are SA node, AV node, sinoatrial node, atrioventricular node. Then it flows to the bundle of his. This bundle of his gets bifurcated into called bundle branches. This bundle branches will get bifurcated many times. We call it as Purkinje fibers. So the electrical impulse which is generated or originated from the SA node will flow to the parts like this and to the AV node. AV node is for acts as a delay line. So from the AV node, the impulses goes to the bundle of his, to the branches and to the Purkinje fibers. So we can measure the electrical signal at the surface of the heart. So this SA node is otherwise called as the pacemaker. So we can see the ECG waveform. So three characteristic features of the waveform are easily identified: the P wave, QRS complex and the T wave. P wave is associated with the activation of the atria, QRS complex is activation of ventricle, T wave is the repolarization of the ventricle. So how will the clinician diagnose the ECG? The shape and duration are very important for the clinician. So waveform depends upon the lead configurations used. In general, he looks critically at various time intervals, polarities and amplitude. So time interval, polarity and amplitude will be used for him to diagnose whether the ECG is normal or abnormal. So you can see the normal ECG signal. So here P wave is the atrial depolarization, QRS is the ventricular depolarization, then T wave is the ventricular repolarization. So here this normal ECG signal, you can see some PR interval, PR segment, QRS interval, ST segment, ST interval, QT interval. So all these will have a specific value for normal condition. So if it varies from that specific value, then that means the ECG is abnormal. So here PR interval, beginning of P wave, beginning of Q wave is PR interval, Ending of P wave and beginning of Q wave is the PR segment. So similarly, ending of S wave, beginning of T wave is ST segment, and QRS interval is beginning of Q wave and ending of S wave is QR interval. So similarly, they have defined different intervals and segments and assigned each values for this measured values for normal conditions, and they have fixed up the range. So for P wave, the amplitude must be 0.25 millivolts, R wave 1.6 millivolts, Q wave 25% of R wave, T wave is 0.1 to 0.5 millivolt. The duration PR interval is 0.12 to 0.2 second, QT is 0.35 to 0.44 second, ST is 0.05 to 1.5 second, QRS interval is 0.09 seconds. For diagnosis, the cardiologist will look for the heart rate. The normal value lie within the range of 60 to 100 beats per minute. So 60 to 100 beats per minute depends upon the person for under different conditions. If the person is thin or fat, or if they have done exercises, so the heart rate will vary from person to person depending upon the body and the environment condition. A slower rate is called as the bradycardia. So slow heart rate is called as bradycardia. Less than 60 it is called as bradycardia. Higher than 60, higher than 100 it is called as the tachycardia. Bradycardia exists when for the elder persons under normal conditions, and tachycardia exists for the persons who have undergone exercises. Cycles must be evenly spaced. If not, a condition called arrhythmia may be indicated. If PR is greater than 0.2 seconds, then it suggests a AV blockage. So you must know what is electrical axis for measuring the ECG or ECG. It is defined as a line along which the greatest EMF is developed at a given instant of time during the cardiac cycle. So that greatest instant of time will give us the magnitude of the different waveform. So that is how we study the ECG signal. This axis shifts continuously through a repeatable pattern during every cardiac cycle. So under what happens when there is an abnormality condition? So under pathological condition, altered path of the excitation of the heart, changed origin of waves, altered relationships of features, changed magnitudes of one or more features, and differing durations of waves or interval. So we fix up the electrodes, that is called as electrodes. The wires that is connecting the electrode to the machine is called as the leads. So we connect from right leg to right arm, left leg to left arm. So they are called as RL lead. So right leg to right leg is called as RL lead, LL is called as the left leg lead, and so on. So practical points you must consider is to ensure that the recording technique is uniform and to reduce the number of variables influencing the tracing, there must be effective contact between the electrode and the skin. So if the contact is loose, then there will be some artifacts while recording the ECG signal. And one more thing is the subjects should lie flat on their back, or lying on the side, or sitting up on the chair while taking the ECG will alter the electrical axis. So these are the electrodes placed onto the human system for measuring the ECG. So they place one in the right arm, left leg, and right leg. So this right leg is termed as reference, and the other you can measure from right arm to left leg, RL lead, from left leg to left arm, LL lead. So like that you can measure the different ECG conditions. So with this I conclude this session. We have seen about the what is ECG, what is the circulatory system, how the electrical activity of the heart flows from the SA node to the surface of the body. Then what are the ECG waveform, how PQRST occurs from the ECG waveform, what are the different normal conditions, how to diagnose, what is an electrical axis, and what are the pathological conditions, what do you mean by electrodes and leads, and how to place the electrodes. Thank you for listening.